Good evening, all. So, welcome to today's session. Today, we will have a brief session. There is one student who is stuck in submitting the IBEC project exam, and I'll be assisting him because of the deadline. But I did not want to postpone the session. As we are waiting for our colleagues to join, it is good if I give you an opportunity. Just give us a recap of what we were able to cover yesterday. So today, I just want to start from Rachel. You can maybe, if you're in a position to speak, you can just give us a recap of what we learned yesterday. After Rachel, we can have also Ephraim, but let us start from Rachel.
Hello, I hope I can be heard.
Yes.
Okay, so what I remember from what we did yesterday, I think we defined data science and then went ahead to distinguish between a data scientist and a data analytics. Went on to, you explained about business analytics. Then we went through the example of someone having a lot of data to analyze and another one not having data at all. So we saw the difference between one who had to now set up a questionnaire and collect raw data before now they analyze, and the other one who already had the data and had to now analyze using historical data. Then I think you also went through what we do with data, the data cleansing and such like so. So thank you.
Okay, thank you so much, Rachel, for giving us a recap of what we learned yesterday. However, you haven't gone into details, and I think it was Ephraim. Ephraim, what do we say data science is all about? Maybe now you can go a bit deeper.
Okay, good evening.
Good evening.
Yes, I think we can do a small recap of what we did yesterday on the introduction on what data science was. And we learned data science is quite a big domain that deals with the vast volumes of data, which uses modern tools and techniques to make business decisions. And we touched on a various way of the terminologies that we use, and also like a process of getting the data. And when you get the data, there is the data pre-processing. Yeah, that is a way of the like a class labeling. That is arranging the data according maybe to a category, depending on the data that you have, maybe to have the correct data, maybe have the male and female, you have maybe height and the like. Then there is data cleansing. Maybe the data you have collected is not well defined, so you remove maybe the errors and also missing points on data. Then the next there is we learned about data balancing, and also we also learned about the data shuffling, where you rearrange the data points to eliminate unwanted patterns and improve on the predictive performance to be able to have maybe a linear way of or a pattern that is going to give you a good maybe the performance or the end result. We also did the masking. Yeah, that is now where we learned currently we are having to conceal confidential data of maybe the clients that maybe you took the data from. We are not maybe able to really open it to all other maybe the clients we are giving. Maybe you consider that data just to conduct maybe analysis without compromising maybe their private details. Then we went ahead a bit to differentiate the roles of a data scientist and maybe a data analyst, and also a business analyst, as you said. Business analyst, he is able to make decisions using historical data, while the data analyst, he is able to make predictive or the future plans or make decisions of a business. I think that's the way I got maybe my recap of yesterday's class. Thank you.
Okay. Thank you so much. I think you have highlighted most of the items that you are able to see. We defined, of course, data science. And as we said, what came up very clearly with regards to the definition of data science, it was that this data science is going to keep on revolving due to advancement in technology. And as we saw that when technology advances, it means also the way data is generated will keep on changing. Then we looked at the two major categories of data. We looked at traditional data and big data. And we say that traditional data mostly is very organized in nature. And as compared to big data, we say that it is voluminous and it travels with high velocity and so on. So we went further and looked at what do you do to your data. So we had two scenarios there. The first scenario that we went through is that someone had data already, and the second one, they did not have data, so they had to collect using a questionnaire. Then we went further and said, yes, in both two scenarios, yes, you have the first situation whereby you have to collect the data, and another one that you had ready data. But we found out that that data is not always ready for consumption, and therefore that brought us to what we call data pre-processing. How do we try to look into that data to make it understandable for further analysis? We looked at the common pre-processing items like class labeling, data cleansing, data balancing, data shuffling, data masking, mostly in big data. And the data masking, as it has been said by Ephraim, is that mostly we used to conceal private personal information or even company information that should not be accessed by a third party. Then now, today, as for those who have joined late, you are doing a recap. I had informed the rest that we will have a very brief session because there's one student who is stuck, is doing exams, and is stuck in uploading the project exam, and the deadline is tomorrow 8 a.m. So I have a session with him, and I hope you accept my apologies because your time also will come. So today we are going to look at where does data come from. Unless there's a question before I go here, is there any question on what we learned yesterday? If you got an opportunity to go through the video and so on, is there any question?
Hello.
Yes.
I don't have any question.
Yes.
I'll just for you to share the slides for yesterday and today. where we can get, for example, if you can share a link on our group, something like that.
Okay. I'll
And
share the G Drive link.
yeah, okay.
Okay, thank you. Any other question you had? Something else? Okay. I can proceed. So maybe you can mute in case you are not speaking, so that we can avoid the background noise. So the next question is that where does data come from? That's the question that we need to ask ourselves. And as we have seen that we have two major categories of data, we have the traditional data and we have the big data. So first of all, we want to start from the traditional data. And maybe before we go further, these infographics that have just input there, they are very intentional. Like you see someone using social media, we are going to see which kind of data is generated there. Then we have another person there seated just like I think it looks like something like a bank or forex trading and so on. So we can now look at where does traditional data come from. So some of the areas in where traditional data may come from, you can have basic customer records. You can have maybe historical stock price information, like how is the stock market performing, maybe performed in last year. You can have that historical data. So, and when you are talking about these basic customer records, they can contain information like, for instance, the customer ID, that's identity document. Maybe in case a customer has ever filed a complaint, maybe it can show how many times they have filed a complaint. Maybe the amount of money spent in a single purchase, if a customer is a repeat customer who keeps on coming and purchasing the items. If they are part of the members maybe of a scheme, if we are talking about pension, other basic customer information that maybe you can collect is their address, contact information, and so on. And you find out that all this data that is being collected is very relevant and useful. So when we look, for instance, the historical stock price data, it can contain dates of observations, the name of the stocks, and their prices. And these are not only the traditional data set that we have. We have a lot of a traditional data set. You can have historical weather data, historical health records, and so on. Then the next one is big data. So when you look at big data, the infographic that I have used mostly, we have this Facebook, social media. We have these guys who have some kind of wearables and so on. A wearable is something like a gadget. For instance, you can have a watch maybe that collects certain data about temperature of a place and so on. Those are the one that can like can measure, I think maybe heartbeat and so on. Those are wearables. All are collecting data and mostly big data. So what is coming or what is clear nowadays is that we have a growing number of companies and industries that use and generate big data. So, for instance, when we are looking at the online communities, for example, when we are looking at Facebook, when you are looking at Google, when you are looking at LinkedIn or financial trading data, that is a growing number of companies generate such kind of data. And also, when we look at what called the machine data from sensors in industrial equipments, also amounts to big data. And I have talked about the wearables here, and I have explained what it entails. In fact, it was when I saw somewhere there was a gadget that was being installed in an athletics pitch to be able to be measuring the temperature. I don't know which country, was it Rwanda or Kenya? I saw it, but I did not go keen into it. All that is used to collect this, what you call the big data. So currently, the volume of digital data amounts to, this is just an estimate, about 3.2 zettabytes, and 90% of this data has been gathered in the last 2 years only. Just imagine, in the last 2 years, 90% of this data has been generated. We don't know how the future will look like. The amount of data that is going to be generated, because we have a lot of the fourth industrial revolution. People are using these smart gadgets and so on. Then, having seen where we are getting this data, both the traditional data and the big data, and the next question is, who handles the data? That is the next question, who handles this data? So, first of all, we have what we call the data architects. These are specialists who deal with raw data and pre-processing, and also their role involves creating databases and maintaining them by a different name. Basically, what happens in most organizations, we find out that data might be stored in what we call SQL Server. So, but we have someone, for instance, if I want to, maybe AFRIS CDSA wants to store the data with regards to their students for March 2023 intake. The role of data architect is to come up with the fields, like how are we going to store this data? And when you will be learning the SQL unit, you will get some of this knowledge, like I want to store this data. First of all, I want to have maybe the student name, the student admission number, and so on. Just a minute. Okay, sorry for that. So I'm just going to take you through the data architects. Then I think from tomorrow we will proceed from there, because I have to assist that student, but let me explain better. So in organizations, as I said, you might have someone who creates those fields in case you want to store your data. So they are able to come up with various fields, like the name of the students and so on. So whenever now this data from your end, you just input in a portal, then the data is being stored in the database. So also we see that we have titles that are similar in the roles they play and so on. But also, mostly we have what we call a data engineer. In fact, data engineers are very rare in Kenya. Mostly these people deal with big data, architect and data engineers. One of the guys that will be training you on machine learning is a data engineer. He's both a data engineer and a data scientist. So mostly what these people do, as we see that the data architect create the database from scratch, what happens is that they design the way the data will be retrieved and processed. That's a data architect. But what does a data engineer do? So a data engineer uses the data architect's work as a stepping stone and then processes, or what you call pre-processes, the available data. And I hope you already understand what data pre-processing is. So these people are able to ensure that the data is clean and organized and ready for the analyst to take over. So I hope the difference between the two is very clear. Between the data engineer and data architect. Data architect stores how this data is stored, how it is created, and how it is retrieved. But now the data engineer does data pre-processing to ensure that the analyst now, the rest of the team, can work with this data easily. Then we have another person called the data administrator. This is a person who controls the flow of data in and out of the database. So in some companies, you cannot connect to this data directly. You are just allowed to maybe go to the data administrator and able to give you the login details. So with big data, almost the entire process is automated. So there's no need for a real human administrator. So the database administrator deals mostly with traditional data. That's why nowadays we have data engineers and so on because of this. So I just want to give you an opportunity to ask 1-2 questions, then we will proceed from there tomorrow. As I said that we will have a very brief session, but I just want to ask, maybe let me start with Ferran. Ferran, have you understood the difference between a data architect and a data engineer very well? Ferran Junior?
Yes, I understand.
Okay, thank you. Philip?
Yes, I've understood.
Okay, thank you. Any other question? I really apologize for making the session brief, but I have just to assist that student.
The last question, I don't have any other question, but share the slides, only that.
Yes. I'm going to share right away in the group the slides and the recording I have recorded.
Okay. No, okay.
Yeah. Okay. Thank you guys. Sorry for having a short session today, but tomorrow we will have a full 2 hours. Have a good night.
Yes, sir. Good night.
Good night.
Good night, sir. Thanks.